Hello everyone, welcome to the session. So in this particular session, we will talk about the analysis part. In our last part, I hope everyone remembers, we have seen that what are the steps required to construct an algorithm. And analysis is the last step where we see, and I have told you also that this is a very crucial step because from that particular problem itself, if we have various solutions, we will be able to differentiate that which one solution is working better as comparable to the other one. Now, with that particular statement, you guys will be able to understand that what is the time complexity part, right? So basically, whenever we are talking about analysis, we will be talking here in terms of two broader categories. First of all, when this analysis will come into picture, if any problem, which is suppose P1, is having more than one solution, for example, solution S1, solution S2, and solution S3. Now, when a problem P1 is having more than one solution, at that point of time, how can I differentiate that which particular solution is working better than the previous one or the other one? So here, the analysis part will come into picture. Okay, suppose you have constructed the algorithm pretty well. Now you have to compare that which solution is having a better performance as comparable to the other. How will you compare? So there are two factors to do the comparison. One is something called as time complexity. Whenever we are talking about time complexity, so it is the time which is required to execute the code, execute the program that you have written, right? This is something which we are saying is a time complexity. And second thing is the space complexity. Now, whenever we are talking about a space complexity, its simple meaning is that you are, whether you are using any extra space to execute that particular code. If yes, that is something which we are saying as a space complexity. I have given you the example also in the previous video. I hope everyone remembers, where I told you that suppose you are doing some problem and one problem is solved using maybe 100 milliseconds. There is another problem which is solved using 50 milliseconds, and then there is another problem which is solved using 30 milliseconds. So which particular approach or which particular solution will be the best preferable? Obviously, you will say which will take a minimum number of time, right? Now, coming to that question, obviously in our algorithms, we will not talk about in milliseconds. It's just for your understanding, I am talking like that. But usually in terms of analyzing the time complexity and space complexity, we use asymptotic notations, right? Asymptotic notations. Now, before moving towards this part of asymptotic notation, let me talk about that how many types of analysis do we have. So, whenever we are talking about types of analysis, so here time complexity and space complexity are the tools with the help of which we can do the analysis. But how many different categories of analysis we do have? Here you will observe that we have two different kinds of analysis. One is called as a posteriori analysis. And another one is called as a priori analysis. Posteriori and priori. Now, what does that mean? When I'm saying posteriori, it means that here we are working with the problem which is actually dependent on what language of compiler and what type of hardware I'm using. So when I'm saying a posteriori analysis, it is actually dependent on the type of hardware and the type of compiler that we are using. Type of compiler, or I would say type of hardware and language of compiler, right? And the language of compiler. It means that what I want to say here is that a priori analysis is something which is independent of both of these things. Means priori analysis is not dependent on what kind of hardware you are using, what is the language of a compiler that you are using. Now, apart from that, when we talk about posteriori analysis, it usually provides us exact answers. It usually provides us exact answers. Whereas when we are talking about a priori analysis, in that particular case, first of all, it is independent of both of these things, whether it be a part of compiler or the hardware, they are independent. Apart from that, it is giving us the approximate results. So here we are not getting a exact calculated results. Okay. Now, these are the two basic differences. Apart from that, you can say that here for every particular analysis, you will get some sort of different answers. Here you will get some sort of similar answers. Okay, so somehow we will be able to correlate that point. Now, we got an understanding that we are having two different kinds of analysis. One is called as a posteriori, another one is called as a priori. When we talk about posteriori, it is somehow dependent on what kind of hardware I am using, what language of compiler do I have. But when we talk about priori, it is independent of both of these things, right? Secondly, we have seen that in case of posteriori, it is giving us the exact answers. Whereas when we talk about priori, it is giving us approximate answers. What does that mean? For example, if suppose there is a layman person, or if suppose there is someone who will not able to buy a supercomputers or a good computer, it means at that point of time, posteriori will always give the bad results because it is highly dependent on that. But mainly when I'm talking about a priori analysis, it depends on the logic, right? It doesn't depend on what is your hardware. You can use a local machine as well to generate a good output because your logic should be good. So, and one important thing is that now if I'll ask you that which particular analysis usually we do, so your answer should be that we usually do this a priori analysis, right? Why? Because as a student, we can't buy computers to generate a good result. But as a student, we can obviously write a good logic to generate the good algorithms, to generate the better results. Now, this a priori analysis is basically, we will study in our next upcoming videos, where we will talk about this time complexity and space complexity aspect. So usually, this you should know that whenever someone is talking about analysis, that which kind of analysis you are doing. So your answer should be that I don't have a good machine. I don't have a good supercomputers. But I do have a mind. I do have a super mind, right? And I can write a good logic. So that's the major reason, because it is independent of the hardware, because it's independent of the language of compiler, because it's giving us the approximate answers, and that's what we want. We are not here to deal with the exact time requirement. So that's where we want approximate answers, and that's where we are getting the asymptotic notation, which will give us the approximate time complexities and the space complexities, and with the help of which we will be able to compare that which particular algorithm or which particular code is working better. Let me give you one simple example. I hope that will make sense to you all what I want to say here. For example, let me give you one simple example. I want to do the summation of natural numbers. What is the meaning of natural numbers? I hope everyone knows. Natural numbers will start from 1 and it can go until anywhere. For example, I will take one data structure list in Python, okay? And I am saying that I am having top 5 natural numbers, okay? And what I want is that I want to do the summation of that. So what I will do is that I will create one variable named result, and I will call one function which will, what it will do is that it will generate sum of natural numbers. Okay. Now here we will pass the same list. Now what will happen is that we can print the result we can say that sum of top 5 natural numbers is. Now here what we can do is that we can simply print the result here. Right? Now what we can do, we need to define this method. Now here what we can do is that we can say def, here we can write the list that we are using here, right? Okay. Now what we can do, we can do one for loop. I hope everyone is aware about the concept of the loops data structure in Python, how basically loops will work. So there are mainly two loops that we have, for loop and while loop. So what I will do is that I will make one for loop which will start by default from 0 and will go until the value of length of the LST that I have, right? This is what I am saying here. Now what I will do is that I'll take one variable which will say total is something which is equals to total plus the value of the array of or the list of I that I have. Okay. Now what I will do is that I will simply return the total. If there is someone who is not able to understand the code, so it's okay. We will do more oftenly in the upcoming sessions, right? It's just to demonstrate you that why we need actually the time and space complexity. Here if you will see, I am returning this. Let me try to just see this. So sum of top natural numbers, here we are returning wrong. So we should return out after the completion of for loop. So now we will get the correct result. Now the same thing I can do with some another method. I hope everyone knows that the sum of n natural numbers will be, we have one formula. What is that formula? I hope everyone knows. This is n into n plus 1, right? Divided by 2. In this way also, we will be able to calculate the sum of n natural numbers. What is n here? N is the how many number of elements I do have in the list. Now if I will do like this, let's see what's the answer we are getting. We are getting again 15 because actually the sum of this 5 top numbers, which is 1 plus 2 plus 3 plus 4 plus 5 is 15 only. It simply indicates that in order to get the sum of the natural numbers, we can do with the help of two methods. Just now we have seen. One, with the help of direct applying this formula, which we have already studied in our 10th, 11th classes, right? That the sum of n natural numbers will be n into n plus 1 by 2. Apart from that, we have seen that the same thing we can calculate with the help of this for loop. Which one is better? In order to solve one problem to calculate the sum of n natural numbers, we have two solutions now. One is with the help of a for loop. Another one is with the help of applying a direct formula, which is n into n plus 1 by 2. Which one is better? Now in this case, if you know that what is the time complexity required to run the first code, what is the time complexity required to run the second code, similarly if you know that what is the space complexity requirement is there, then you will be able to distinguish that which particular code is working better or which particular code number 1 or the implementation number 2 will be better. See, both are giving me the correct results, but which one is better is our next important thing. That's where analysis will come into picture. That's where you should appreciate the point of analysis that we are going to discuss in our next class. Now I hope that everyone is very much enthusiastic and is able to understand the importance of the time and space complexity. I have given you one good example as well. If you are not able to get the code, please don't worry. You will be easily able to get in our future classes. We will do coding only, right? But I hope that the point that I want to state here is pretty much clear to everyone. If you still have any sort of doubt, do let me know. Apart from that, I think it's pretty much enough for this particular session. I'll see you all in my next video.